We're live from the 2015 Robotics Leadership Summit at GE's Global Research Center in Niskayuna, New York. We're here with Rodney Brooks, the founder of iRobot and the founder, chairman, and CTO of Rethink Robotics, whose Baxter robot helped usher in the collaborative robotics revolution. So first, Rodney, thank you very much for talking to us today.
Great to be here.
We just a little bit earlier, we heard you offer a talk on the perils and rewards of deploying robots in new places. Could you just kind of give us the key highlights of your talk?
Yeah, I was trying to point out that you may have a great robot and it may look like it fits an application, but the customer may not like it for all sorts of reasons and may want to change things. I used one example with the Roomba. The Roomba, there's been there's 14 million of them out there. But people have always said, well, why doesn't it go in straight lines? Why does it go in this random search? Well, we had tested, and randomly going in random directions is like a person does it. It actually cleans the carpet better. But recently, iRobot came out with a version of the robot, the 900 series, that could go in straight lines, exactly straight, because that's what a lot of customers said. It should do it that way. They did a great technical job. They used vision to do V-slam to get those straight lines. And now you look at the reviews and some people say, well, why does this cost more than the old ones? Well, it costs more because now you have to have a supercomputer doing VSLAM in order to go straight lines. And actually you're better off with a robot that doesn't go in straight lines because it goes on the different maps of the carpet and cleans better by doing it multiple times. So we see that again and again with as you get into new domains. At Rethink, we've got a robot which uses force feedback and can do very precise alignment with force position, by putting something up against a stop, just like a person does in a press brake, say. But and that enables you to have very imprecise location of the parts that it picks up because it's going to get it all right in the alignment with the end part of the task. But a lot of customers say, but it's not as precise in its position control as other robots. And we say, but you're not going to use the position control in this task that you want to do. And they say, yeah, but I don't want to buy a robot that's not as precise as other robots, even if it's only half the price. I still want the precision. And so you got to work with customers, so we built a very precise robot as a result. But a lot of customers will use it where they don't need that precision, and it's hard for people to rethink how they're going to do tasks.
Do you find that to be one of the bigger challenges in kind of bridging the gap between what the robot can do and what people sort of preconceived expectations?
Yeah, I was a bit surprised, and I shouldn't have been in retrospect. I said, we're developing a new sort of robot. It's collaborative. It's used in a different way. I don't have to unsell the old way of doing things, so I'm going to go with customers who've never used robots before, so I'll just show them how to use the new robot, and everything will be fine. But so many customers map it back to what they know about the robots they've never used, and then we have to go through a process so they can see the advantage of doing it the new way.
And this is still with industrial customers?
That's with industrial customers, yeah.
So same for probably people who buy the Roomba and people
Yeah, and I mean, I've seen this again and again, and robots going to Mars, robots in the military, everywhere, every domain that I've been involved in.
So with that type of, with those type of little obstacles built in, where do you see the technology going in the next 5 years? What's it going to look like in, let's say specifically the industrial space?
Well, I think demographics drives things. And demographics is driving the need for more robots in the industrial space. The average age of an American factory worker, I think, is 56. The number of 19-year-olds in China is dropping 30% in a 10-year period. That's where they get their labor source from. So demographics is saying there's not enough people to do the tasks. We need more robots. But I think demographics is also going to drive towards robotics being necessary in elder care, because there's many more older people, less younger people to provide services. And I'm a baby boomer. I'm going to want to stay in my home as long as I can. I'm going to maintain my dignity and my independence. And having machines which can help me maintain my independence is going to be very important. And I think it's important for lots of other people. We're starting to see now researchers tackling this problem. I was in Tokyo last week at IREX, big show. In the research section, there were a lot of research institutes there in Japan where already the demographic inversion is really severe, working on robots to help people get into and out of bed, to help them walk and to lift things, so that they can maintain their lifestyle independently longer. So I think over the next 5 years, we're going to see more and more research start to pop out. We actually here at this event, there was a company which had a robotic walker to help people, elderly people, be able to walk. So we're going to see more and more of that at the research level over the next 5 years. And I think in the 10-year time frame, then there's going to be enough knowledge what works, what doesn't work, to be, that's when we're going to get into real deployment and real production of robots to help the elderly. So 20 years from now, it's going to be lots and lots of robots helping people maintain their independence.
How much of that, stay specifically on elder care, how much do you think in that time, let's say the 20-year time frame, are things like computer vision, the industrial internet or the Internet of Things connectivity, how much of those do you think are going to advance robots and where they're at?
Well, I think we see connectivity in homes coming more and more. We see the smoke detectors, the thermostats, everything starting to get connected. That's Internet of Things in the home. A lot of the technology that's being developed for the IIoT, Industrial Internet of Things, trickling into those other places. Just going to continue. But I see three big areas for research necessary in the home. I call them the 3 M's. One is mobility. How do you get a robot that can move around a house? Because lots of houses, they may just have one step here. They may have a whole staircase, but even with just one step here, that's enough to stop a wheeled robot or any sort of wheeled robot that you want on your floors. It's got tracks that's going to rip it up. So how does the robot get around delicately in a house, which does have level changes? They all do. Mobility. Second one is messiness. People leave stuff everywhere, and this is, I think, is really being benefited from the progress in computer vision, the low-cost 3D sensors that are coming from the gaming industry. If you go to either a robotics conference today or a computer vision conference, you will see hundreds of papers on using 3D sensing to deal with messy, cluttered situations. That's important in the home. Third one, though, is a little tougher. That's dexterous manipulation. That's been around a long time. Involves mechanism, these beautiful hands. It involves materials. The material of our skin is very important. It involves embedding lots of sensors, and it involves algorithms. So to make progress in that, you have to have a team that can tackle at least those 4 things all at the same time. I see that as perhaps the toughest frontier in research for general deployment of robots.
Do you feel like there's enough inertia or forward motion in the progress of these 3 M's?
I think mobility is some. I think messiness, great. I think manipulation is lagging. But if we got, and partially that's because there's been so many failed attempts over the last 40 years, people are a bit gun-shy. But if we made progress on dexterous manipulation, it would not just be good for the home, it would be good for the factory, it would be good everywhere. It would be good for fulfillment centers. What's happened in fulfillment centers is basically the automation and robotics has got rid of a linear motion, because that we can do, but still grabbing the object that's got to be packed is done by a human hand.
So, and I guess this is my last question. A lot of this conversation at the broader level keeps coming back to the amount of AI that's necessary to do these tasks that you're saying should be coming in 5-20 years. Where do you fall? How much cognition is necessary?
Well, I'm not sure cognition, definitely a lot more perception. I think the press and some people who are well known but are not in the AI field have misunderstood the level of artificial intelligence that's available. It's not just something you can pour into things. It's still very much, what is this particular task I want to do? I'll build an AI system to help with that particular task. Doesn't necessarily translate much to this other task. So there's going to be more AI, but it's not just flowing like wine and honey. It's still hard work for every piece, and isn't just going to come magically. A lot of hard work left.
And each question, as you said earlier, could be 100 research questions to get an answer.
Oh yeah, these are all, and that makes it very hard to predict. I'm going to try and do this. Is that easy or hard? We don't. Some things have turned out in the last 5 years with deep learning, have turned out to be great. That's why the speech interaction systems we see, both Siri, Amazon Echo, other places that we now talk to our machines, gotten so much better due to deep learning. We did not predict that 5 years ago. Deep learning is going to hurt. We're going to be able to help speech systems because we're going to learn the early breaking up the speech signal instead of the hand-built models. We did not know that 5 years ago. It's been beneficial, but we don't know which place something is going to be beneficial next because they are hard research questions, and what we do know about research is sometimes things are easy, sometimes things are way harder than we estimate. We just don't know until you go and try them.
A lot of fascinating questions and a lot of questions about questions.
Yes.
Rodney, thank you very much for taking the time.